Alrighty, so you will remember who was pretty cocky, pretty kind of walking with a swagger yesterday since they survived the formula derivation yesterday. Eh? Yeah. Did you go home and watch the video again just because it was so good?
No.
Didn't think so.
Definitely not.
No. Okay. Well, you might remember. I of course got these memorized because I've been using them for probably well over half my life. Yeah, indeed, well over half my life. Yep. So what are they again from yesterday? Zach, remember the first one? How about if I get you started? VF equals? Yeah, VI plus AT. Thank you, Jason. No? Okay. VF squared equals VI squared plus 2AD. And then the other one was D equals VIT plus 1/2 AT squared, right? So we did question 1 yesterday. I gave you a chance to do question 2. Many of you got it right. Would you like to see the solution to it? Yeah? Is that a general yes from everyone? Okay. So here we have a ball initially at rest. So my initial velocity is 0. The acceleration is 3.3. It accelerates for a time of 7.5 seconds. We are asked for how far, the D. How far would it move if it started at 4 meters per second rather than rest? So actually, you're really, part B is basically do the same thing except change the VI, right? So which one has D, VI? Oh, this is easy, isn't it? D equals VIT plus 1/2 AT squared. That's going to be 0. Do I need to write 0 times 7.5? If you're one of those people that likes all that stuff to be perfect, then you go right ahead. But I know that 0 times whatever is 0. 1/2 of the acceleration, 3.3. The time is 7.5 squared. And just work it out, and there's your answer, right? For the most part, that's a pretty straightforward question. That might even be a multiple choice question on a test. Okay? For a couple reasons. 1 being it's easy to mark. 2 being that you need to practice with multiple choice questions. I got 92.8. Is that what you got? Excellent. What would be some common mistakes that you could make there? I guess. Do you need the brackets here, Ryan? It's all multiply and squared, I think. I don't think the brackets would cause the number to. You're right. Brackets often cause problems, but in this case, there's no plus or negative, so it shouldn't matter. Yeah. And as a teacher, we put in distract, and they do that at the universities. They put in distractor answers that would be the answer you would get if you don't square it, right? That's what they do. Okay, so watch out for that sort of stuff, right? It's not always going to be C, by the way, as well. There could be also something like, there could be an answer of 92.8 meters per second, right? And put that in part A. Watch out for stuff like that. Part B would be exactly the same, except what? Here it would start at 4 meters per second, so there you'd have 4 times 7.5 plus 1/2 of 3.3 times 7.5 squared. If you want to show your work like this, you can. I don't expect it. You could just put the answer. Like, I mean, you could go from this step to that step if you want. All in all, pretty easy though, right? Yes, nod, would you agree? More or less easy? It's basically pick the right formula, the old plug and chug kind of thing, right? We're starting you off small here, right? It's going to get more complicated. Okay, let's look at this one here. A boy sliding down a hill accelerates at 1.4. If he started from rest, on what distance would he reach a speed of 7 meters per second? So I'm asking for a distance again, but I'm not giving you the time. This time I'm giving you the final velocity. So what do we know? Acceleration 1.4. He started from rest. The initial velocity is 0. What distance would he reach? VF equals 7, and we are looking for displacement. What new formula has A, VI, VF, and D in it? Well, Mr. Bennett, it's VF squared equals VI squared plus 2AD. The final velocity is 7 squared. Initial velocity is 0 squared plus 2 times 1.4 times d. Can you go right to that step? Some of you probably can. If some of you want to have an intermediate step, I'm okay with that. Again, on a scale of 1 to 4, kind of hard kind of thing, where would you put that? Would you really?
Well, it's too that hard.
Approaching, no, 1 to 4.
One's the hardest or?
No, 1's the easiest.
So 2.
Not a 1?
Do you want it to be 1?
Oh, I'm thinking it's pretty easy, isn't it? Like, how could I make it any easier?
1.5?
No, how could I make the question any easier?
1 point. You could give us all the, everything?
Circle the answer?
Solve or whatever.
Basically.
I can make it a 4 by saying, what is the boy's name?
Ah.
Trevor.
That's a good name.
Always.
Do you want to try number 4? You go ahead and try number 4.
Only if it's 4.
Okay, well, let's see here. Starting from rest, end of a runway undergoes a constant acceleration of 1.6 for a distance of 1,600 meters, which is a mile, by the way. What is the speed? What is the time required for takeoff? Oh, yeah, this is easy. VF squared equals VI squared plus 2AD, I think, right?
Yes.
Yeah.
0 plus 2 times 1.6 times 1,600. What would be the one common mistake that people would make here? They would forget to
Square root.
square root, right?
71.6.
That sounds right. 71.6 meters per second? Easy stuff, right?
Well, you know.
What is the time required for takeoff? Which one did you use? Here's the one that people are going to screw up. They're going to do this, aren't they?
Oh, no, I didn't do it. Yes.
What's wrong with this answer? What's wrong with this?
It's the average.
That's the average velocity. This is the final. What was the initial? 0. What's the average? Halfway between 0 and 71.6. Wrong. Right? You could divide it by 2, yeah. That would work, right? But that is wrong. In fact, I'm going to leave that like that to show how wrong that is. How are you going to do it? Well, I would solve it like this. 71.6 is 0 plus 1.6t, so t is 71.6 divided by 1.6, right?
24.75.
Yeah, about 45 seconds. Now, you've been on planes before, many of you. Does it take 45 seconds to go from one end of the runway to take off? 45 seconds is a long time. Ryan, how long would you estimate a plane to go from rest to takeoff in seconds, based on your past experience?
10 seconds.
Yeah, maybe 15, that's probably tops, right?
I was going to say half, but
Half, but 30 seconds, you mean?
probably half of that.
Half of that, yeah. Probably somewhere in the 15, maybe 18 seconds. Once she gets going pretty quick. Yeah. So,
It takes probably like 20 minutes to go from rest to get to the runway, and then.
well, that's true, yeah. I sat on a runway once for like an hour and a half waiting. Just as we were ready to go, there was some small plane that blew a tire in front of us, and they had to come out and sweep all the rubber up and everything. Oh, are you kidding me? Which one of these numbers do you think is the one that's causing that to be wrong? Which one is unrealistic? 1,600 meters or 1.6 for acceleration?
1.6 meters per second.
Yeah. Do planes accelerate much faster?
Yeah.
Yeah, I would say so. Would you think it's about a mile long? I would think at least. It might even be short. I bet you that's at least 10 times the amount, right? So I'm guessing this is longer, and that's much, much greater. Okay. Now, this is example 12 in the book. You will not understand how they do it. Here's what I want you to do. I want you to draw two cars just like that at opposite ends of your paper somehow. You can page over to well, then draw it on there. I don't care where you do it. Quickly, draw one car at one end and one car at the other. Okay? Tractor, whatever it is. I don't care. I want you to label the left-hand side Fred. I want to finish the first one. And the right-hand side Barney. You'll get time. You got lots of time to work tomorrow. Lots of time to color and make them all pretty.
Oh, I never even finished it. I don't know how to do it. So.
Oh, really? Okay, well, off to my house. Fred here on the left, Barney on the right. Okay, well, let's read the question. Fred and Barney are at opposite ends of a 1 kilometer long drag strip. So draw a line between them and mark the distance, what? 1 kilometer, right? Fred accelerates from rest toward Barney at a constant 2 meters per second squared. Barney travels toward Fred at a constant speed. How much time elapses until they collide? They're going towards each other. They are going towards each other, and then they are going to collide, right? So I want you to do this right below it and show them colliding. Okay, like that. And in the last 6 minutes here, I want you to discuss how you're going to solve that problem. In the last 6 minutes, try to figure out a strategy to solve this problem. I will ask you Monday. I will ask every group for an opinion. Monday.